So now let's look at connecting the switches in parallel. So here are two switches. I've turned this one on its side so we can see the connections. So the switch connections are this one and this one. This switch connections are this one and this one. And instead of connecting them one following the other in a gap there, we're going to try and bridge them across in parallel. So in order to do that, well, that's going to be a rather fiddly thing to do, isn't it? Let's have an extra wire there. We could clip that one onto there and now hook this up to one of the paperclip switch connections. There it goes. And then the second one to there. So you get the idea of where our parallel connection comes from. There it goes. So now let's try and operate the switch. Well, one switch, this one here, can operate the light bulb. What about this one? I see. So either of these two switches can power the same or complete the circuit to control the same light bulb. So what happens when you press both? Well, we're not going to notice the difference. We're not going to notice the difference when you operate both. Either one can control it. So we could say this switch or this switch can control the bulb, whereas in the series circuit, both switches had to be connected in the on position to turn the light bulb on. So this type of circuit's got a different sort of application as well. What would it look like in practice? Well, that's how we started. Now we need another switch. Let's have it there, look. And these two switches are now connected together. And we could simply do the little bridge across like that. So it's as if the electricity from the battery can flow through this switch if it was closed and light the bulb, or the electricity from the battery could flow through this switch if it was closed and then complete the circuit to the bulb lighting it up, or if both switches were pressed. So I suppose you could say either or both switches could control the lamp in a parallel circuit. So that's our switches connected in parallel.